I think that's a good time to hand over to Chris Graham now, if that's okay. Chris, who's going to talk about the use of numbers within some teaching that you've done.
Thank you, Michael. Let's put up my slides there. And thank you, Christian, for that first talk. Yeah, so as Michael says, I'm going to be talking here about a specific application of numbers to some programming modules at Newcastle University. So I've been teaching programming in Newcastle for a number of years, and over at that time, I've sort of developed the courses and for a variety of reasons gone down the path of wishing to assess programming exercises in numbers. So this talk gives a little bit of that background, a little bit about how I've approached that and some of the issues that we've tried to solve. So my apologies to some of that. I can see some numbers fans. I think you know who you are in the audience today, and those people I think have seen similar talks over the past year or so from me, but it's not slightly different. So yeah. So I'm going to be talking about my experiences using numbers in these programming modules. If you want to access these slides, they're up on the web. I think we'll be able to share that link towards the end. And I've actually gone away from a traditional slide format here. I'm actually using the format of my my practical handouts so that you can see how exercises are embedded in the content. So we'll see that a little bit later on. So in Newcastle, like I think many departments, mathematical sciences departments around the UK and around the world, have more and more started to embed programming inside the curriculum. So Newcastle is no different, and we teach two programming languages. We teach Python and R. And R sort of from a statistics point of view, as we run modules in probability and computational statistics in R, and Python from a more general computer programming and also numerical methods, so sort of applied maths and physics point of view. And I look after the stage 1 and stage 2 Python modules. We moved over from MATLAB about 3 years ago now, and have been sort of developing those modules since. And these modules are compulsory, so we sort of embed programming in later stages. In our stage 3 and 4, our programming sort of mixed in with the other content, but these are sort of dedicated modules. The structure is quite well established. So when I came in, there were 3-hour practicals. We put in a 1-hour lecture. We moved that to a sort of lecture practical format. And that was very popular. What we were seeing really was students get hold of a practical worksheet, and they just have at it without reading, without taking due care to understand what they're doing. So this is quite a successful move to have a lecture where we can introduce some of the concepts, do the admin, the general lecture admin, recap on previous material. And actually students really liked seeing sort of live coding, seeing somebody going through the process of doing coding and getting things wrong and fixing them, and seeing that whole process of how it happens. So so this was I think a successful move to this format. So our 1-hour lecture is fairly standard lecture format, quite a bit of interaction, but covering these various things. Our practicals are very hands-on, so students work through what was originally a PDF document, actually, and is now an online web page like this one. And they work through a mixture of code and theory and diagrams, and then exercises. And so they have a number of exercises to do. And during that time, I'm on hand. I have a team of demonstrators on hand to help students out, to guide them through that material. So students really, it's quite a very large class. Some of these classes are 200 students. So it does rely on students being able to work through a lot of the material in their own, at their own pace. So there were some challenges to this, and certainly when I took on the module, some of these were quite significant. So the first, I think, which many of you will appreciate if you teach in this field in your course, is that we're teaching students who have signed up to a maths and statistics, even physics degree, and what they haven't signed up to is a computer programming degree, and we're asking them to do quite complicated stuff with a computer. And some of them have background, some of them have done an A-level in computing, some of them are frankly scared of computers. They don't know how to copy and paste. They they have issues just getting started. So we have students from very different backgrounds and experiences with computer programming. And so we need to accommodate, of course, all these different students. And so a couple of things that we noted from our practicals early on, and so I guess illustrated in my diagram there. We would often be, our demonstrators would often be handling what I'd call very low-level queries. So they would be sort of, how do I get started with this exercise? And the demonstrator would very politely say, well, read 2 paragraphs above, it tells you, or I've got this error message, what can I do about it? Very low level stuff. And what we really wanted was to have deeper conversations with students, why are we doing this? Why doesn't your code, work? These sort of high level discussions, and we weren't able to have those because we were swamped by these basic queries. So we wanted to get around that. And we also found early on, we had too much reliance on group work and collaboration. So while it's great to encourage students to work together, what we found was, as my middle student is there, we found students, looking over another's shoulder without really building any competency in programming, and they then struggled at later stages of their degree. So we sort of backstepped a little bit on some of that sort of collaborative work and building content that is aimed, very much at building individual confidence in programming. So these were ideas that, long before pre-pandemic, these were, ideas that certainly been floating in my head, and we were iterating learning material over time to sort of move towards a more independent learning material. Students could self-learn, self-assess, get that feedback loop that Christian was talking about to move forward. And then, of course, this was all accelerated. So I don't know if we can use the use TALMO as a verb, to TALMO, but I have here. So we COVID TALMO'd our practicals. So basically, we moved online in 2020, and we needed to be able to deliver what was an in-person practical with demonstrators helping, and deliver that online. We didn't have that opportunity to have demonstrators sat next to students to help them. So this really fast-tracked this idea of building more independent learning material going forward. And that's when numbers came in, and actually the idea of having formative assessments in my modules originated far before COVID. And I remember the first student who asked me. So we have these we used to have these numbers practice tests available for all of our modules for stage 1 and 2 in our programs. And I remember a student coming to me and saying, is it possible we could have numbers practice material like we do in our algebra and our calculus, our logic, and or else? And I went, oh, okay, yeah, we can do that. And so I started developing questions. And at first it was sort of, it wasn't marking code directly, but it was multiple choice or finding ways to work around being able to give students feedback. And I wanted to use numbers for that for a number of reasons. So one is as I just said, it's very familiar to our students. So they use it for every other module. The other is that it's rich with features. So Christian's shown you some of those there. It gives that instant marking and feedback. You can add randomization. You can add alternative answers, to catch common errors, adaptive marking, explore mode. It had all these features. And the other thing that was big for me was I wanted to mix code question types with other question types. So I wanted to be able to ask the student, how to write some code, or how to interpret the output of some code in terms of mathematics. So this is a mathematics module. So it wasn't about just coding, it's about interpreting and presenting results. So that led us down the path of numbers. And in the latest version of the extension is very, very clever. And I have much to thank Christine and my other colleagues for this stuff. So we've developed an extension to numbers that marks code. And the technical bit here is gloss over, but essentially it marks code in the web browser. So there is no server running the code, it's running right there in the web browser. And that's brilliant. It ties in with everything, all of the other ways that numbers works, that you can use it without dependency on a server. And it also allowed us to share what we were doing with people outside of Newcastle. So in our previous iteration, we were sending code to a server and getting a response back. So it's very, very clever. And I've got some examples in my handout here. So this is a very, very basic example. And I'll show you how some of these features fit in. So in this example, I just have to set a variable to the first element of a list. And numbers can mark that answer. I'll tell you a little bit more about how in a second, and give me that instant feedback. And it can also do some of this other stuff like this, catching common errors. So if you're an R person, you might think that the first element in my list is as index 1, the thing in the bracket here is a 1. And I've caught that error, just like Christian was catching some of those common errors earlier. Equally, I might have the correct bit of code there, but have forgotten to set my variable X. So it can catch that and give me that feedback. So creating a bit of a feedback loop. So how does this work? Well, it works by allowing us to do unit tests on a student's code. So they are tests that we can run that return a Boolean, a true or a false. And the extension actually allows us to run more than one of these. And this allows for some very sophisticated sort of part marking. And I've got a demonstration here actually with a plotting question. And to save a bit of time, I've just pre-populated my answer box with a solution. Something I often do, ask students to modify a bit of code to make it correct, or give them the first part of a solution and let them work on it. And in my pre-populated solution here, I've got almost all of it correct. And you can see some of the marking. So I really do have the correct function here. I have the correct range of X values. I haven't used the correct, so I've asked for 150 linearly spaced values in my X array. So I can go ahead and edit that code and rerun it. And it'll say, great, I've got that bit right now, haven't added any labels. Okay, so I can go ahead and add some labels to my plot and so on. So I can have this sort of quite rich template of feedback to give to students. So how do I mix this in with handouts? So my handouts, a bit like the text here, I can mix in some theory, I can mix in exercises, I can give the students some code to try out. My handouts have a Jupyter notebook format, so students can run through the code that way as well. And embedded inside that are questions for students to try. So, so this one is related to the one above, and students will, read the content and then try that out. And quite often these aren't code marking exercises. So these might be, going back to the more traditional, number entry or mathematical expression type questions that numbers can do. So this one asks for a numeric value. It's asking me, how far have I shifted this array round? And again, not sure what's happened with my tick there. Again, I can catch those sort of alternative answers to mark. So this particular question has an answer that goes one way or the other, so it can be 3 or -5. Okay, and in interest of time, I won't go into the next one in detail, but the extension integrates features like explore mode. So in this question, create a class for a rectangle, and it allows the student to build up a solution. So rather than getting to do everything up front and, you know, create this object in Python with all these attributes and methods, they can build up a solution very slowly, which is sort of beneficial, particularly for formative use. So the last couple of minutes, just a little bit about assessment. So as well as these handout exercises, I provide students with a set of sort of accompanying practice material each week. And then for summative assessments, I do make use of this stuff, but it'll be often in the format here where I have some questions with code parts, and then I'm asking a student to maybe upload a plot to our virtual learning environment, and I'll mark that by hand. And that's quite an efficient way to do the marking. So I'll let the computer do the bits that it can do easily, and let me do here, you know, presentation of a student's plotting. So students like this, they really appreciate the practice. It's getting very positive feedback, and I'm still going through sort of iterating this. So the current academic year, I'm using this new version of the extension, which doesn't rely on a server for the first time, and sort of picking up, you know, picking up a few bugs and picking up a few improvements, iterating towards next time. And there's possible application to this, I think, beyond our modules at Newcastle that we'll come to next semester as well. I've got a paper in preparation, so that's going to MSR Connections, so please do keep an eye out for that. And a big thank you both for listening, and also to Christian and my other colleagues in the learning unit here at Newcastle for their support with this. Okay, thank you.
That's brilliant. Thanks very much, Chris. And I think we should also sort of record a note of thanks to you, Christian, and before that, Bill Foster, for all your work in actually making numbers freely available to the community for everybody to access. I think that's an important note of thanks. Dimitri, I see you have a hand up, so I'd like to bring you in for a quick question for Chris.
Yeah, thank you. Yeah, quick question regarding this new version, which is not based on the server. If I download a SCORM file and then upload to Canvas, say, will it be based? Should be something set up in Canvas to be used this WebR and Python something, or it's independent? You're mute. Oh, you're muted, Chris.
I'm on mute. It's been a while since I've done one of these on Zoom. All of the libraries that are required are included in the package. So if you download your SCORM package, just like any other numbers, upload it wherever it goes, and the code marking will work. So there's no reliance on anything else. It's all self-contained. There were some questions there I showed with sort of uploading plots and things. So we normally have sort of like a separate submission area for that, or say, you know, complete the numbers part here, and then go and head to the submission area and upload your files. That's how that works. Yeah.
Thank you. And if I may, very quick, another question. Do you have some export import things? Because, for example, what you explained, I normally did it R Markdown, or now in Quarta, and all other such things. So if I have something in Markdown format, all this stuff, can I upload this to Numbers?
I think the
and probably also other way around. If I created a lot of things in Numbers and then I want to create a nice PDF from this and also distribute to students, can I export this from Numbers?
Yeah, the R Markdown to Numbers, I think the answer is probably not easily. I think you, Christian, might be able to add some more. Numbers has a sort of option to display as a worksheet, so that would give you a printable version of your document, or, you know, it renders as a web page that you could then port to wherever you like, depending on the output of your R Markdown. So if that is sort of HTML, then I imagine some of that will be, you know, usable to paste into wherever you need in Numbers. It's the syntax is so there are some special functions that display code in a question, so you'd have to merge it into there.
Okay, thank you.
Okay, brilliant. Thanks, Dimitri. Thanks, Chris. I think again, virtual round of applause there for Chris's talk.